Okay, welcome to Masterclass 2, Turning Effect of Forces and Energy Work Power. I hope you used the checklist well. Let's go to the first question, Learning Objective 5B. Recall and apply the relationship that moment of a force equals to force times perpendicular distance from the pivot to new situations or to solve related problems. Right, so really quickly, if this is a force, this is a pivot. Okay, so this is the pivot. Okay, we're talking about turning effect of forces. That means previously when we talk in dynamics and when we talk about acceleration, how the force results in acceleration of an object, you usually have a point object and then you have a force, right? So we just assume that object is really, really small, and then based on the force, we can describe how it's going to move, right? And that's really helpful for analyzing paths of objects. But what happens now if the object is not a point object? What if the object is a long object and you apply a force here? Does it simply accelerate straight up like this? We know that it doesn't in real life, right? So once the object has dimensions, we see that it starts to turn about certain points, right? And so to begin to understand that, we learn about this moment, which is how force causes objects to turn about pivots. So when we're talking about moment, it's always about a pivot because the object always has to turn about the point. So note that the pivot is absolutely crucial here when we talk about this, and everything is going to be depending on where the pivot is and of course where the force is. So we have the force here, the line of action of the force, and then we and there is this perpendicular distance. This perpendicular distance, very, very crucially, we need to know what this distance refers to. Okay, let me use blue instead. So we have this distance here. This distance is always a distance from the pivot. Okay, can you see here? From the pivot to the line of action of the force that is perpendicular. Okay, so it has to be perpendicular. It's the distance that is perpendicular to the force to the pivot. Okay, another way of thinking about it is simply the shortest distance from the force to the pivot. Okay, the shortest distance from the line of action of the force to the pivot. Of course, that's also the perpendicular distance. Okay, so to find the moment is the force times distance, right? And again, this formula tells us a story. It tells us that the moment depends on two things, which I think you should know by now at this stage. Force times perpendicular distance, such that a larger force will cause a larger turning effect or a larger moment, or a larger distance. The further away the force is from the pivot, the larger the turning effect as well. So moment depends on two things: force times the force and the perpendicular distance. Okay, so this is the story that this formula tells, which we're going to use to figure out these questions. So pivoted window weighing 100 newtons is open with a force of 30 newtons. So know that the weight of an object always acts at the center of gravity, so it shows that the weight acts in here at this position. It's open with a force of 30 newtons, so you push up here with 30 newtons, everything's in the diagram. What is the magnitude of the resultant moment? How do you find the resultant moment? What are the directions in moment? Okay, so the directions in moment is always, because it's turning effect, it's either this way or this way, right? I guess this way. So what do we call these two directions? We call it clockwise and anti-clockwise. Okay, so in case you don't know what direction your clock goes, this is clockwise, this will be anti-clockwise. Okay, so the resultant moment just means what is the you add all the moment together. It's just like resultant force, right? What is the result of adding all the moment together, right? So you just take the bigger one minus the smaller one and you find out what it is. So let's calculate the moment of the two forces. So there are two different forces here. These are only two forces: the applied force and the weight. What's the moment of the applied force? So the moment of the applied force, which direction is this about the pivot? So the pivot is here, the force is here. So can you see that this is a anti-clockwise, right? Anti-clockwise direction. So ACW moment equals to 30 times perpendicular distance. What is the distance from the force, line of action of the force to the pivot? Can you see it's 0.2 plus 0.5, so it's 0.70, and then you would get 21 Newton meters, right? What's the clockwise moment due to the weight? Okay, so this is clockwise moment, can you see? So it's about the pivot this way. So this will be 100 newtons times, what's the perpendicular distance? The distance from the line of action of the force to the pivot is 0.2 meters. So note that the distance is always between the force that you're looking at and the pivot. So between the force and the pivot that you're looking at, 0.20, this will give me 20 Newton meters. And so what's my resultant? ACW is bigger by 1. So my resultant moment is simply 21 Newton meters minus 20 Newton meters, which will give me 1 Newton meters. And actually it's going to be anti-clockwise, right? So answer is A. Alright. Question 2. A cyclist applies a vertical force of 110 newtons on a bicycle pedal of a bicycle as shown. She travels along the pedal, moves a circle radius 8 cm. For the pedal in position shown in the figure, the line of action of the force is 5 cm from the pivot. So they've already very kindly showed you the exact distance you're supposed to use, okay? Which is which is this distance, because they tell you that the distance, the line of action of the force is 5 cm from the pivot. So this is what it can look like. This is the force, this is the pivot, the shortest distance or perpendicular distance from the line of action of the force. Okay, so calculate the moment about this. This should be pretty easy. Moment equals to F times D, perpendicular distance. So F times perpendicular distance. It's always a good habit to write the formula first. So 110 times 5.0 equals to 550 newtons cm. Okay, note that they asked you to give in cm and they gave you in cm, so that's fine, don't need to convert to meters. Okay, part B, the pedal moves from position A to position B as shown in the figure. Explain why the force applied at A will have a different effect from the same force applied at B. So force applied at A will have a different effect from the same force applied at B. So if we look here, and the pedal is here, right? The force, a vertical force applied here, what would be let's say it's the same force, right? So even if it's the same force, 110 newtons. So the same force, same vertical force, 110 newtons downwards applied here, why would it be different from the force applied here, right? So again, the different effect comes from the turning effect of forces, right? So what do you need to consider? You need to consider the perpendicular distance from the line of action of the force to the pivot. So at B, I think the perpendicular distance is more straightforward. The force is here, the perpendicular distance is here, right? This is the perpendicular distance, which is 8 cm, okay? But what about at A? What's the perpendicular distance? Actually, the line of the action of the force is down here and it goes right across the pivot. So the perpendicular distance is actually 0. What would that tell you about the moment of the force? The moment of the force, F times perpendicular D. If your D is 0, your moment will be 0, right? Because anything times 0 is 0. So the downward force here has no turning effect, whereas the downward force here has a really large turning effect. In fact, it has a maximum turning effect because it has the maximum distance from the pivot in the whole path. So the reason why the force at these two different locations has a different effect is because it has a different perpendicular distance from the pivot, and that's what we're going to try to explain. Okay, so I've already put the answer here. When the force is applied at A, the perpendicular distance, this is the key thing you're trying to explain. The perpendicular distance between the line of action of the force and the pivot is 0. So what? So why does this result in different effect? So there is no moment produced by the force about the pivot. When I say there is no moment, I'm basically saying there is no turning effect, because moment means turning effect, right? They're asking for a different effect, so I'm saying there is no turning effect produced by the force about the pivot. Okay, then at B, so they ask you to explain A and B, right? So B, perpendicular distance between the line of action of the force and the pivot. Please be very specific about this, between the line of action of the force and the pivot. Show off your knowledge, okay? Show that you know it's between the line of action of the force and the pivot. Is the greatest at 8 cm. So this is the key thing I want to keep seeing, right? Between the line of action of the force and the pivot. And so, because it's at the greatest, it has the maximum turning effect about the pivot. So the maximum turning effect is produced. So compare this, no turning effect, compare this, maximum turning effect. Why? Perpendicular distance from the force to the pivot is different. Okay? I hope that was easy to understand.